I didn't really prepare anything, but it should be okay. I'll first start off with how I got into coding, and then just go step by step throughout my career, I guess. Well, from my studies and to the career where I'm currently at, and how I come to this point. It's going to be a bit long at the front. As you know, I'm Korean, and so we have the mandatory military duties picked out as, it's like a admin role, but more tailored towards like kind of training, take care of training materials, and then prepare the training materials. After everything's done, I'll just collect the materials again and then kind of maintain it and keep track of all of the inventory and stuff. The role kind of involved of being like the assistant for the captain, where the captain is in charge of what the company where it's 100 people, 100 soldiers. And so I was kind of like the assistant as well, where I wake up every morning and I'll get the daily and the weekly plans prepared for my captain so that he looks over it and then he plans out his day and stuff. So I had a lot of like admin work to do. But because I was inexperienced and my rank was low as well, I needed to use the computer to do my work, but like people higher ranked than me, like the officers, and they would like kick me off the computer saying I need to do this now. And so I had to use my free time, my times during the night as well, where everyone else is sleeping, but I still had like work left, and then I had to finish those like within the day. So I was really overworked at the time. It was really tough for me. There's a lot of different types of admin stuff, inventories tracking and like reporting and stuff. I felt like I didn't know coding at the time. I knew there was a thing called coding. Obviously we use computers and stuff, that somehow they were made. But I had no idea how they were made. But I just kind of had the sense where these type of things, that I'm doing it really inefficiently, but I feel like this is when coding would be used to automate things, right? It doesn't feel like too much of a complicated thing to automate, right? If I just knew coding.
You think that it could help you in your
daily
tasks?
Yeah, like save me some time so I can get some sleep. Yeah. But during that time, I had no idea what coding was, and no one within the base, also like within the company, knew what coding was as well, so I didn't really have a choice. Because of that experience, because of that time, I told myself when I go out and finish my military service, I'm going to learn coding because it's going to help me, with
do things in a more efficient way.
Yeah. So it was like a really grueling experience in the army. I really didn't get enough sleep, and I was having mental breakdowns and stuff. And it was a bit traumatizing. So I felt the need to learn this. So after my military duty, I went back to university. First year, my bachelor's was in human genetics, so I was just doing biology stuff. I bought myself a MacBook because I thought, coding is... I had an iPhone, so there's apps. So I thought maybe like coding, making apps is coding. So I thought I'll just start with that. So I bought a MacBook and then I started learning Swift. So that's I don't know if they still use that.
That's
language.
Interesting that you started with Swift.
Yeah, so I don't know if they still use it. But
I think they do.
Yeah, they do? Okay. I started with Swift. I bought this online tutorial on how to make apps with Swift, making card game app stuff. I started off with that. I didn't know Python or like R or stuff like that at the time. I did know R, but like in my first year of university, R is like a statistics-oriented language, right? We were using R, but in our first year statistics class, we were using like graphical user interface of R to do like basic statistics stuff. I didn't know that was coding at the time, but we were all just using graphical interface, so it was just clicking, right? So it didn't really get to me. But my second year of university, I came across a module called Bioinformatics. So this was first learned like R is actual programming language. The thing we used in first year was just a graphical user interface, just to make like simple stuff easier, but actually it's a proper language. And we're just learning the basics of it. Like I was listening to that lecture, and I felt this is like I had no idea there was like coding integrated into like biology, right? So I was in university for learning human genetics. I was learning coding on my own, which was app building. It's different from the stuff with related to R, but like I was still learning coding, right? I finally saw
you can
the
connect
two.
it with the
Yeah,
fields.
yeah. So yeah, I saw that you can connect these two. I was just learning them separately, right? I loved that lecture. Like on our last year of university, we needed to do a project, right? So like a final year project. So I asked him, I wanted to do like 100% dry lab project where I'm just encoding. In biology, you kind of split into wet lab or dry lab, where wet lab is you go to the lab and you wear the lab coat and you do the pipetting and stuff and do like the actual like wet lab stuff, right?
Could you explain? That would have been my question.
Yes. Yes. So, and then dry lab is all like computer stuff. I mean, you can do a mix if you want. Some people do a mix. But I said, like, I'm not interested in going to the lab and I just want to do like computer stuff. Coding, statistics and stuff. And he said, oh, great. Matt, don't you have a dry lab? Like the student here, he wants to do a completely dry lab project. And then like he loved it because like each year in like biology, like life sciences department, like there's 300 of us per year and everyone wants to do wet lab stuff. Like they came to do biology and then like they're told to do like statistics and like coding and stuff. Like they don't like that, right? There's people just find it a bit difficult, but that was like the niche for me.
Yeah, so you were one of these rare students
just
really interested
like the
in
really
that part.
So Matt said like, yes, I have a completely dry lab project, and I started doing the project. So at first the project was he had a postdoc who was working on this thing, and she was, let me just log into.
Was that the first time you also got in touch with Python then, or did you work with Python before?
No, that was my first 2017. This was my first project. The thing that I just described happened in my second year of university. The start of my final year was when the project started, but we have a summer break between then, right? So my supervisor, he told me there's this site, Software Carpentry, and they have lessons to learn basic, Bash, Git, Python, and R, just very basic stuff, and just told me to go through it. It's like, okay. And so during the summer, I went through all of them, and then I was assigned this project. This is a biology thing, so you don't need to like understand the details. That's not the point of this explanation, but so it's like there's the strip of DNA and we want to sort of build incrementally, like rebuild it's a prediction model basically, where we don't know what the sequence is, but we know we have like different bits and pieces of it, and so we're just kind of like matching them together and puzzling it to make it longer and longer. But I mean, it's a prediction model. But that's the kind of concept. But you see how my first code, like I said before, is lots of if, else if, this. Like it's a lot of, and then there's like for loops and it's just nested if else statements and like lots of for loops within it, like dictionary inside a dictionary is it's very inefficient, very hard to read and understand, but this is how I started off. Project went well. I kind of had something work, and then I had a gold standard data to like compare it to, and then it kind of looked similar. So, but it didn't get used in the end for publication, but I guess it was because it's just too messy to understand. So,
but you finished the project successfully. It worked in the end.
So the postdoc probably like just rewrote everything from scratch and used that as a publication. But yeah, I started off like this. After the project was over, I still went off, before starting my master's, I just went through the code again and improved some different bits. Some of these like packages I didn't use. I later, after the project was over, I just improved on the code. Let's try using the logging method to get more informative logging messages so it's easier to debug or just kind of figure out what's going on while it's running. And ArchParse, it's making this code into a command line tool rather than just running the script itself. And then using collections package. Why did I use a collections package? And just using different types of dictionaries, not just the normal dictionary that comes with it. Just trying different classes, and I was just kind of experimenting what I already had. Just building on top of it, just improving what I already made.
So was the hard part like to make the code work, or was it also like to just from the sense of the field of biology, what you were trying to do there, to combine that? Or so did you get stuck often just because of the code not working? You knew what you wanted to do, but how to show it, how to code it actually, and then go back to reference.
It was a long time ago, so I don't really remember.
Yeah.
So it was 6-7 years ago, right?
Yeah.
So it wasn't exactly easy at the time, but I had someone who, like, beside me, who was helping me, teaching me some basic stuff. And the basics, like the very basic stuff I learned by going through this, but this is just going through the very basic stuff. But
this was enough to
get me started. And say like programming with Python, this covers basic data types, lists, strings, integers, floating points, and dictionaries and sets and stuff. Just goes through that. I remember the postdoc who was supervising me, she told me that you can put a dictionary inside the dictionary. At the time, that was a very like big wow thing for me. But like now it's just like,
of course you do that.
It's nothing special. It's just that's how the data work. But that was something like a breakthrough moment for me. But so I at least had someone next to me who was helping me out with these things. But after this was over, and then I kind of had a starting point where I can build upon, right? Improve. So I was just reading different things during my summer break before I started my master's. Just improving the code a bit. And then my master's started. And then on my master's, we also had to do a project. We had classes and assignments, courseworks and stuff, but we also needed to do a 1-year long project, right? So we needed to contact the professors or PIs, principal investigators, ourselves, and ask them if they have any projects available for a master's student. And then I contacted a few, and then I clearly said, I wanted to do a completely dry lab project again, right? I think me wanting to do a completely dry lab, going through the dry lab path was what got me into my master's program as well, because I'm the minority. Like there's a high demand for bioinformaticians, but not enough supply of it, right? So in my interview, I said like, I love doing bioinformatics. I want to go do more like coding in like that sort of area rather than just like wet labs.
They didn't have enough students wanting to just do that. Actually, most of them want to go for the wet labs.
I think so.
A different experience.
Mostly. I mean, like if you go to like PhD sort of level, a lot of people do feel the need to learn bioinformatics then, because it is a really useful field. So a lot of people switch then as well. But like I started really early on, right? I think that was a big plus for me in my CV. So, and I contacted some PIs saying I wanted to do a lot of just completely dry lab. I hear you're doing these type of things, and then one of the professors replied saying, yes, we have a project for you, and took me on. There was a principal bioinformatician in that team that was supervising me. So then again, I had a second, he's my sort of second teacher, right? So my first sort of teacher was the person when I was doing my final year project in Bachelor's, and then this is my second sort of teacher. I didn't really have like a mentor afterwards because I was experienced enough to mentoring other people, and so I was kind of, but he was sort of my last mentor. He became my boss later on, but that's we're kind of working together then. My first project was Python based, but my second project is something called genome-wide association study. It's something we do in genetics, where we get the genotypes of individuals and then we statistically calculate for each variant. If a person has, say we have like 1,000 diabetes patient and 1,000 control patient, people who don't have diabetes, and we look at a particular genetic variant. If there's, out of the 1,000 people with diabetes, say like 800 have this allele of the genetic variant, is like different versions of it. If 800 of them have this particular variant, whereas the control samples, the individuals, like only like 100 people have this particular variant, you can kind of see like the statistical difference between the two groups, right? So you kind of, it seems statistically there's a probability that there is some biological process going on that increases the risk of diabetes, for instance. You need to do follow-up studies. You need to actually prove this in the wet lab, but this is what we do in like the dry lab. We first do like a mass survey type thing, right? So my master's project was a GWAS study. This time I was using more R, because R is more sort of suited for statistical analysis compared to Python, where I use Python for more sort of general purpose usage. You can do statistics on Python, but it's just more convenient. There's less code to write if you're doing the same thing with R. So I prefer using R in that case. So my second mentor, he was teaching me how to use R, and then he kind of got me to learn overall basics of other stuff as well, like Linux, like Bash. How do you navigate through the file system, and like how do you like pipe these different commands to get what you want out of it?
Why was that necessary for you to learn Linux?
Because the lab we were working at, they have a high performance computing cluster. So it's a Linux server. It's a farm of Linux servers. So we would access it by the terminal, and then it doesn't have like a desktop, like graphical interface, right? So you need to interact with it by the terminal only.
Okay.
So I needed to learn Linux. I mean, it's a Linux server. So,
Understood.
so if you're going into any type of coding, you're eventually going to have to learn how to use Linux. First project I did because the software carpentry thing, that they have a course on Unix shell. This is how to interact with the Linux system. But my first project was just writing the Python script and then just running it on my laptop. So I didn't need to like navigate to different places and find these files or like manage these. I didn't need to do a lot of that. But when I was my second project, I needed to do a lot of that, because I needed to grab like files from there, read file from here, and then manipulate it, and then output to a different location within the file system, blah, blah, blah. I learned more sort of general skills there. And I was taught from the very start to use Jupyter notebooks. So you document everything that you do, so it's easier for you to look back on as well if you need to go back to anything.
Also has a very clear structure.
Yeah.
Notebook, no?
Yeah.
I feel like this is the standard now for people also starting to learn Python.
Yes.
You know?
So yeah, because we're working like together as well, we need to keep everything documented so other people can look at your work as well.
Do you use, because you could use also Git for that, right? For documentation.
It's
easier to access for everyone in Jupyter Notebook? Or?
It's a different Git is used for version controlling, just keeping track of your code, like your scripts and packages, that type of thing.
Who has done what?
Yes,
So,
yeah.
when?
Yeah. Whereas Jupyter Notebook is, I mean, you can push your Jupyter Notebook on a Git repository as well, so you can clone it from different places and then look at it, or just make it public so that you can have access to it. But yeah, it's a different sort of purpose. I can't clearly elaborate it here, but once you use it, you would, it's very, you understand the difference. Git, I did use a lot in my first project. As you can see, I don't have a lot of commits, but so that I can keep track of what I was doing, and then what's updated. If anything was wrong, I can go back to a previous version. And then Jupyter Notebook I started using on my second project when I'm doing more of a research style project.
I mean, it's very different to Git because it's a kind of it's like a coding environment, right? The Git is more to just store your versions of code, right?
But I mean, like for web developers, don't really need to use Jupyter Notebooks because,
Often they use an editor like VS Code.
Yeah, they use editors. They can, if they have things to document, they can just document on Notion or some other documenting app rather than Jupyter Notebook is to have your code and documentation side by side, because what you're documenting is about the code, right? But it makes sense to use Jupyter Notebook in research environments because you're running things and then you're describing what you're running.
Yeah, it makes sense.
Yes.
Yeah.
So if you're coding in any capacity, you should definitely learn how to use Git. If I'm interviewing people for a new position in my team, if they're like good with everything else, but they say like they don't use Git, they don't know how, or like they refuse to use it, like I wouldn't pick that, like I wouldn't hire that person. Like whether or not like you're good or not, like I don't care. If you should at least know Git. And that's like the basics of basics. Like not using Jupyter Notebook, that's kind of acceptable. I mean, you can pick it up later if maybe you have your own way of working, but Git, like there should be no excuses for not knowing Git.
Yeah.
So yeah, second project, I think there isn't much to say now, I guess. I may come back to it if there's something that might have been useful to mention, but I can't think of anything at this moment. One thing to mention is I've learned how to use a job scheduler while I was doing my master's project, because it's a HPC environment, but this is more research. If you're going to be doing research, this is something that will be useful to learn, but you're not going to be doing research, right? So I don't think that would apply to you so much. But at the time, I was using LSF, I think, at the time during my master's. Now I'm using Slurm at my current lab. My previous job, we were using Grid Engine, some Grid Engine. It's a bit out of date now, but yeah. Job schedulers is say you have analyses, you need to run like hundreds, thousands, millions of like tiny processes or something. Maybe you have like, I work with genetic data and phenotype data, and then we like do associations. Say there's like 1,000 individuals genetic data available, whole genome sequence data, and from that 1,000 individuals I also got 1,000 different phenotypes, their blood sugar levels, their BMI, their that type of biological sort of biomarkers type of thing. And then I want to run associations, so hundreds of thousands of genetic variants, and I have 1,000 phenotypes. I need to run an association for each combination, so it just piles up. The amount of analysis I need to do just piles up to like 10,000s, 100,000, millions. This is where job schedulers come in, where you have a farm of servers and you submit the jobs that you need to run, and then the different servers are allocated these jobs to run in parallel. So that's what job schedulers are. But I don't think you would come across these unless you suddenly change your career to like research. So, but I guess it's good to know. But after my master's, I decided not to do a PhD and start working. I joined a genetics-based startup where the focus was going to be receiving samples, like blood samples from each different patients, and then we're running it through this pipeline we made and generating a report. The scientific idea was based off of research from a different lab. It was kind of a spin-off and then making that as a product, right? I said I would take up on the technical side of things because that's what I was interested in, and in the company there were already people, people with PhDs who were more knowledgeable than me on the biological side of things. So there wasn't really a place for me. I mean, I could if I tried, but I was
really
yeah I was more at that time. I was more interested in like the technical side of things. I was going down a unusual path.
Yeah.
For a biologist. So I didn't really have a mentor then, right? I kind of had someone who was more knowledgeable than me, but like he wasn't like beside me at all times. So I was doing a lot of things on my own. A sample comes in, DNA sequence and the sequence data is uploaded to our server, and then the sequence data then needs to go through our script, which analyzes the data and then it produces the report. At first, the script, say, is like one big script, and you have the DNA data, the input data, and it goes through the script and then it produces the output. Say if that took 8 hours, 10 hours to run, but 4 hours in, an error is raised and it just stops, right? And then you need to find out what the error is, you need to go in, fix it, and then you have to rerun it. You've wasted 4 hours, right? So that was a big problem. That's one of many problems that we had. How can we work more efficiently? Like, started breaking down the script to more sort of manageable steps, go through it, and then, group the different steps together and just split the different steps into different parts of the workflow. So if we go through like one by one, step by step, if say an error is raised in step 3 and then step 3 stops, but because we made like in between steps, right, we don't need to start from the beginning, we just need to fix whatever happened in step 3 and then carry on from then. So doing that, and then like as we worked on and on, we make updates throughout, over a couple of weeks or months, we made updates, right? Like added a new analysis or no. Say it's the same analysis we've been doing the whole time, but we just changed some value to make it a bit more accurate, say. And so we feel the need to rerun the samples that we ran previously, right? Because we improved the quality of the workflow, for instance. How do we differentiate which samples have been run with the new version of the script and the old versions? We haven't been tracking that, so we start versioning. I went to read up on like how others keep track of like versions of software and stuff. It's just basic stuff. But like, I come from a biological background, not like a computer science. If you went through a computer science background, you would have probably learned that, right? But like coming from a biology background, like I didn't have that sort of basics. Just how do I version? So I keep track of the samples and like the versions of the pipeline that we ran for those samples, and then if we needed to rerun something, we can just check what was the last version that they ran, and if it isn't the latest version, we run that sample again. And like maybe it was one set of analysis we did in cancer DNA. There are different things that you want to analyze. There's the single nucleotide variants, there's copy number variants, and there's structural variants, different kind of variants, and you need to analyze them differently because they're different types of variants. Like you need to analyze them differently because they cause different consequences and stuff. So we have to have a pipeline for each of them. Before, it used to be one big thing. That's why it was taking like tens of hours. But now we split them up. And then we use job schedulers to run the analysis separately instead of like sequentially, right? That was inefficient, right? Because it was taking too long for running one sample. So we split them up. We break it into smaller
But let
sets
it
of-
run and process simultaneously
Yes,
instead of doing
in parallel. Yes,
Yeah.
in parallel. So you have to think about those things, like how would I do that? So I made pipelines for each different analysis and version them in each different differently, because say there's like I made an update to a structural variant pipeline, I just need to run the new structural variant pipeline and not the other pipelines, right? But if they're sort of coupled together, like I would unintentionally need to run the whole thing if they were like one big script, right? Just breaking them up, like how would you do that? And other ways of parallelizing this, you can use a job scheduler, or you can use in Python, there's the multi-process package or multi-thread package, threading package that you can use to parallelize. In R, there's parallel package, there's DOMC, like just learning different things on how to parallelize and use multiple cores or processes, threads on how to do things. And also, like, at first I started off working on my own, but like the workload is not something I can handle alone. So like we get more people in the team. Like, how do we collaborate? Like, we use Git to track people's different changes together. We learn about branching in Git, where different people work on different branches, so that we can so it doesn't conflict so often. We just work on different branches, and then later on, once we finish on our own individual work, we can merge
together.
them, and then and then push to production, and then update it and do a more sort of structured way of working, right? And like code, I got really obsessed at one point with code quality. You know, before I knew like how to write clean code, I was just writing and looking at my old code. It looks very messy, not very readable. It'll take a long time to interpret, right?
I feel like today, when you have certain code editors, you can add certain extensions, and then they kind of make sure the code is, I don't know, like indented in a certain way automatically. But that's not just that, right? There's more to writing clean code.
Well, I mean, that's linting tools. You write your script and then you run it through the linting code, and then it cleans it up for you, right? That's what linting tools do. There are different like styles of like coding. So there's in Python there's restructured text. There's Google. They have their own way of writing code, and NumPy, like how do you document so Python have this thing called PEP. Is the Python enhancement proposals. Like, people propose things through this by writing this document, and then this gets reviewed by the core developers, and then they decide whether to implement it. Yeah.
Okay, what good clean Python code should look like.
Yeah. So PEP 8 is about style guide for writing, how to write clean like Python code. There are like different PEPs. If you're interested, you can. I'm gonna talk about this as well later on. But like, so this is like how to indent, and PEP 8 in particular. So because we're working now in a team, I was kind of enforcing writing clean code, because you don't want to be wasting time trying to interpret very badly written code. You just want to focus on the implementation, on the actual work of it, rather than like wasting time to understand, because it's just not like it's not indented. There's inconsistent indentation and stuff like that. It gets frustrating. We have other things to worry about. So it's the little things that sort of add up when you're working. So I was doing some basic, like going through some basic tutorials to my team members on like what sort of third-party libraries we can use. And then other things I had to worry about was but to keep good track of versions, you need to package your code, your pipelines and codes, but also for like redistribution later. Like, we have one server at first within the company, but like if we're gonna move to a cloud service to distribute our workloads, or maybe we want to be a bit more flexible, right? So if we have a server, we have to maintain it, but if for some reason, suddenly if we get like an influx of new clients that want to run our pipeline, right? It'll take time for us to buy new servers and set it up to increase our rate
Capacity.
of output, and increase our capacity. So maybe we want to use cloud services. We did do a bit of that, so to be a bit more flexible. So how would we need to distribute our pipeline to make the transfer easy? We also had like clients where, so we were working with hospitals, and some of the hospitals have policies that they can't take out any DNA data because it's sensitive, to the outside, right? So they can't send the data to us or samples out to us, and they need to run everything within their premise, like within their hospital, right? So like they would prepare a server for us to install our pipeline in it, but like how do we transfer that? Only server they might have is something that is completely different from ours, right? But it's still a Linux server. That's where containers come in. Like we package our pipeline in a container, and then we just take the container file and then put it in their server and then run the pipeline there. So learning how to package your code and using containers. You could use Docker or Singularity. In the scientific field, we use a lot of Singularity. There's a benefit in that because you don't need admin rights to use a Singularity container, but you do need admin rights for a Docker container. And if you're working in a high performance computing cluster, only the central IT team have admin rights to the server, and every other analyst or researchers are just regular users, so they can't use Docker. So that's why something like Singularity was made for that type of use case. The different situations, the hospital might already have the server and they want to have control of it, and they have admin rights and they don't want to give us admin rights, so we would need to prepare a Singularity container. Or maybe we kind of make an agreement where our company buys the server and puts it in, and then we're kind of renting type situation, and then we have admin rights so we can use Docker if we want, but depending on the situation, you need to learn how to use both. Expanding briefly on packaging, I briefly told you before, Git is something that you should always, there's no excuse to not learn, right? But packaging is something you don't need to know it, but I highly recommend you learning it if you want to, have a better understanding of the language, is because if you learn how to package your code, I made this Python package a while back in my free time where I need to talk about testing. I'll talk about testing first, actually. So back to the example where we had a 8-hour running script. That was 8-hour running script. If it fails during the run, and then you have to start over again, but you need to find what the issue was, right? You need to understand the bug to know how to fix it. Yeah, so what's a good way of testing whether you fixed the bug or not? So you go in, so your sample analysis failed, and you read the traceback, and then you identify in what part of the script it fails. You go to that part of the script, you think you know the answer, so you make the fix, and then are you gonna just rerun the whole thing? It's gonna take another 4 hours, right? How can you do
just
that more
to find out that there will be another error? You fixed it, so you lost another 4 hours.
So how can you do that more efficiently? So you need to break up the scripts, and instead of writing like a huge function, you need to break the functions apart so that it's in a more of a manageable chunk of code that you can test. And then there's something called unit tests, where unit test is what this is for. So you have a function, you have an idea of what this function should do, give example codes where in these situations you have an expectation of what the output should be with the simple example, right? And then you set the example input and the example output, and then you run the test, and if that function outputs what you expected, it passed the test, right? But if you expected it to output, say, like a 1, but it outputs a 2, there's something wrong with it, right? It's a simple example. You should, you need to investigate why that's happening, and then...
So first you need to really understand where the bug occurred, so that you can actually then understand, and so you can have different, know which part of the script you have to rerun, so you don't have to rerun the entire script, right? So that's
So, and then there's also the issue where you think, so your bug is fixed, it runs fine, but sometime later you find another bug, right? And then you fix that, but you may introduce the old bug again because of the way you fixed your new bug. But if you wrote the unit test for the old bug, when that test used to pass and now it doesn't pass, it means that old bug has been reintroduced. But because you have that unit test there, you know before pushing it into production that this bug is still there, so you need to fix that as well. So it's a fail-safe, and so I'm learning different things to make my time efficient, right? And this isn't just, these are concepts that doesn't only apply to Python, it just applies generally in programming, right? Whether it's C or R or Java or whatever, they all have like ways of unit testing or packaging or stuff like that. Going back to the packaging, so this is a Python package I built a while back in my free time, where I thought, so there's a way to write unit tests. I like using PyTest tool for running my unit tests, but I also kind of wanted a way of writing tests in notebooks and getting the test codes in the Jupyter notebooks to run, because Jupyter Notebook is made for having documentation alongside your code. You can document in a bit more depth about what the tests you wrote are doing, right? You can document with comments in regular scripts as well, but it's just maybe you have like a bit of a complicated test that you need a bit more documentation with nice sort of markdown capabilities, for instance. So I made this package that kind of covers that. After making it, and I never maintained it because just wasn't bothered. I had other things to do, but I never maintained it. But because I learned how to package my code, how to write the setup.py file, and like the different the basic, readme and license, blah blah blah, these type of things, and like setting up an automated testing actions, the testing workflows. So I think I used GitHub Actions. Did I? I think I did, but it's been so long that I have ran it. So each time, so here in the test directory, I have these set of test files. These are unit tests. And every time I make a commit and push to this repository, I set it up so that all of these unit tests are run automatically within GitHub, and then it gives me a report of saying whether all of my unit tests passed or failed. If it fails, obviously it means I need to debug something. So and then I did all that, and then also read the docs as well. So say read the docs, and then let's go to test my. I also wrote up this thing where if I make changes to my documentation files, it automatically pushes to this read the docs, which is an automated documentation website. And I also, so this package is available on PyPI, Python package index, yes. So when you do pip install?
Pip install?
Yeah, so when you're installing new packages with Python, have you done that before?
No.
Okay, so when you start using Python and then you want to install third-party packages, you're going to be using something called a pip, and you're going to do pip install, and then the package name you want to install. So I'll show you. So here, I have this Python installed. So I do pip, wait, 3. What's the version? Or yeah, Python 3.10. So if I do pip 3 install test my NB, that's the name of my package. This is going to install my package. So now I can import test my NB. Maybe it's not. Let me just check. What did I name my package? Setup. Test my NB. Might be because this is mainly for a Jupyter notebook rather than a. Never mind. It's not important. I'll do something else. Pip 3 install pandas. So it's installing pandas, but I already have it installed. But this is when you do pip install, and the place it's searching is this place, is Python package index. So so test my MB is here. So this is where how Python knows to install what package, and then I did I installed pandas as well. This is the package that it was installing. Latest version is 2.2.3. I also set it up so that if there's an update here, it updates the version of the package in the Python package index as well. I think. I may have not. Maybe I needed to do that manually. But the reason you can find this package here is because I, at some point in my life, pushed it here. Okay, so that's why this is how you install. So because I learned how to package, I learned how to write unit tests, and then set up the CI/CD pipelines, and then pushed, and I wrote a simple documentation on how to use this package, and then push this package onto Python package index. People can install it if they want to. I did the whole thing, right? Start to end. So that gives me a very good understanding of how Python packages are made. And like I said, if you go into Python, people use import pandas as PD a lot, using the PD package, the pandas package. But like people just take that for granted, right? Like, what does import?
Yeah, exactly. Yeah, we saw that you're going to have to do that, but I never questioned. What's behind that?
Yeah. So like, where is it looking for that pandas thing? And
it was accepted. That's what you have to do to use it. But
I learned how to package because I needed to know how to redistribute my code to other environments like the cloud or like hospitals and stuff. But by learning how to package, I got an understanding of how the import machinery works. And then I started to question how does it work? Like, okay, I understand how to navigate like with pandas. I imported pandas. There's this function I use a lot, dir. PD, it lists all the Python objects that are attached to this object. So as PD, there's all these objects that are attached to it. So like PD, the arrow D type, like what is this? This is a class in this location within the package. Let's go to pandas. Now we're going into a bit more deep. I want to see the source code of it. Pandas dev. Right, so the source code is in here, pandas, and then it's saying it's located in core. So here, core, arrays, arrow, and then D type, but there's no D type here. Maybe it's in here. D type. So now they're using some other sort of. So they're using some other sort of features of Python packages to sort of simplify things. Like I did pd.arrow_dtype here, but the location is here, but how is this class available just through here is a different question. Do I want to go down that rabbit hole though? Let's see. Yes, okay. So that is importable here instead of needing to import. So we can import the same thing like this. And this is the same thing as pd_arrow_dtype, for instance. Like I have an understanding, after learning how to package, I got an understanding of how packaging works and how the import machinery kind of works. And so I start to question, like, what do these things mean? Like, I've been using import so many times, but I never questioned it. Now, at this point, I am out of beginner level, right?
Yeah.
But I haven't gotten into sort of like the intermediate sort of realm yet. But now I kind of know.
You wouldn't say that,
huh?
like after such a long time, like working with Python and
It's
coding it, that I would call it definitely an intermediate, no?
So I still think I'm an intermediate level. So
if not even.
I don't
like
no. Like I'll explain.
It's been quite years of like.
So what? It's been what, 7 years since I first started coding now. But say there was a pyramid. Say like here's the beginners. So beginners, and then this is the intermediate, and then this is the advanced level, right? So higher you go, there's fewer people, right? There's a lot of beginners, and then there's fewer intermediates, and then there's fewer advanced.
Yeah.
So I'm now at that point. It's been what, 3 years since I've been coding-ish, programming. I think I'm like around here, like on the borderline between beginner and intermediate. I still think I'm still in the mid intermediate, because like the Dunning-Kruger effect, like the less you know, the more sort of like confidence you have about your abilities. You think you know everything and stuff, but like the more you know from then on, you start to realize how
little you know.
Little you know, and then once you go to the advanced, and then your like confidence goes back up, and then like you clearly know what you know and you don't know, and you have a overall like grasp of like the field, right?
I feel like right now you went deep into it, and now you feeling like I have a few more questions, and I
know what I don't know. So there's so much I know that I don't know. So that's why I think I'm still intermediate. Like we have a post for my team, and I'm going through like the applications, and then people are saying like in their CVs, I'm an expert in R and Python, I'm an intermediate on this, but I'm an expert in that. I read that as like, you are no way like expert level. Like when I say expert level, like I think of like core developer of Python level, where so I'm gonna introduce a few people that are worth looking up later on, which should help. But yeah, so I start to have questions on like the basic things that are provided. So like, how does the print function work? Like what happens under the hood? Like what are Python objects? So like, what are the different Python objects? Like I start like printing like everything I can think of. Like I like print, what's a class? Okay. Class syntax error. Why am I like, I do class, but we can set up classes saying my class, and then we do this type of thing where and then we write initialization function, and then self dot hello is 1, I don't know, and then I can make an instance of it, instance of this class, and then this is the class instance, and then this has an attribute of that has 1 saved, but like what's in it, like what's self, and why am I getting a, why am I not able to print class? And like, okay, what else can I print? Type? Like I can print type, but I can't print class. What's the difference between them? Like class is a keyword, but type is a function and an object at the same time. Type is something weird. If you go really into deep with type, like everything is type. Everything is what's a type of a type? Like you start to question a lot of these different things, and then you try printing out a lot of different things, and then you learn a lot of different things, and then I'm sort of out of that beginner phase. Now I read tutorials, it doesn't help me, right? I know the basics. I'm out, like I understand the basics now. So like, what is there to learn from me now? Like, how do I learn from this point onwards? You buy textbooks, and then it'll go through. It says it'll teach you to like advanced, but it's not true. It'll go through the basics like data types and like what a for loop is, what a while loop is, what if else is. Goes through the basics, and then it introduces you to some. Let's look it up. Python textbook. Let's just go. I just want to get an example. I just want to see the table of contents for like any random Python textbook. Okay, I can't find one. I can't find a good example. But like, it's just generally it will be like basics. What is the data types that are available for Python? What is a for loop? What is a if else statement? What is a what's a function? What's a class? Like how to do them. And then it starts introducing you to some built-in packages like how to use the logging package, how to install packages like pandas. How do you use pandas? It makes data frames. How to use NumPy. But those are still like, I feel still like basic level stuff.
Yeah.
You go into more sort of.
That's not what they called it. They was like from beginner to advanced.
Yeah. But and then you go into topic specific stuff like web development, like how to use the Flask framework, how to use the Django framework. And then those are domain specific, area specific stuff. I mean, they are useful. I do think those are more sort of intermediate level, I guess. You need to know the basics to start understanding. I mean, you can jump into like learning Django from early on, right? But
I think you always need to learn the basics, right?
Yeah.
What you're learning is like data types or something that you learn in any coding language.
It's you fall in the trap of, if you go into, for instance, web development early on without knowing the basics, if there's any sort of coding that deviates from that domain, you don't know how to solve it, right? So you in data science specific terms, you overfit for that particular task. You only know how to do that task. So if there's any deviation to that, like you don't know what to do. So you need to learn the basics so that even it's easier, you have a good foundation, so it's easier to learn new things. And even if you're stuck with something, you have a basic understanding of how Python itself works, so you know how to fix things or how to investigate the issues and stuff. So like after I got out of my sort of beginner bubble, the way I started learning was like PyCon. I couldn't find a lot of good textbooks, but I was just learning a lot of different things. So with packaging, let's search Python.
Is PyCon like a channel on YouTube that you have used a lot, or?
No, it's PyCon is a Python conference. It happens a lot of different places. So Python packaging. There's this. If I can find it, I want to show you the one that I watched. And now there's a lot of different videos about Python packaging, but
like when you started that wasn't there?
I mean, I'm sure there was a lot of Python packaging videos back when I was searching for them as well, but there was just this one particular one that it was just like a really old. I can't find it. Anyways, I get more useful things out of like PyCon because they are more of a lecture type thing they do, and they give out like practical things that they tried and what they achieved, and so. But PyCons helped me a lot. I just, even if I don't need them now, I just watch quite a lot of them. You never know what becomes useful later on. So it was kind of like I guess like a hobby in a way. I just watch different things and have things on in the background. So I just passively take in some stuff. But like you search a lot of Python videos, and then I seem to come across a few people where I see them often and like I consistently like their lectures. For instance, James Powell. Oh yeah, wait. He like I watch Python related stuff, and then he's a data scientist. I don't know where he's at now, but like he was at Microsoft, and I quite liked his material. It's quite high level, as in like a bit of intermediate to advanced level materials. But I think James Powell, you might not, if you're still beginner-ish, watching them might not give you so much
A little bit
gain.
too complex, the concepts he's talking
about. Raymond, yes. Raymond Hettinger. He is a core developer of Python. I don't know if he still is. But
what do you exactly mean by core developer?
Yes, I'll get to that as well. I'll get to that. So Raymond Hettinger is a core developer of Python, and his materials are like he's good. Like he's been active for a very long time. He does a lot of live coding sessions as well, so you can see. I like live coding sessions where you can see from like he's writing it, and because it takes time to write, you kind of have the time to process what's going on as he's writing and explaining. If it's a lecture and the lecturer already wrote the code and like the outputs within the slides, you might miss stuff. I mean, if it's a video, obviously you can go back and pause and stuff, but you kind of have to make that mental effort of like going back and then rewatching the part you missed or something, right? Because there's like a chunk of code that it's not too complicated, but it's to just read it and then instantly understand what's going on. So you might still need a bit of processing time to understand it. So I like live coding sessions because it gives you that time to follow along, actually follow along, instead of like watching and then having to mentally sort of understand and then But
he's also explaining, he's live coding, but then explaining what he's doing.
And Raymond Hettinger has a lot of experience in doing a lot of these things, so I think he's a very good communicator. He can get the message across, and is really easy to understand his material, in my opinion. So Raymond Hettinger. And then there's James Powell, who's more into sort of data science stuff. And then there's this guy, and then there's David Beazley. He also does a lot of live. I think all of his talks are like live coding stuff, but his materials are very advanced. There's this what was it? Meta programming. There's this 11-year-old 3-hour video on Python 3 meta programming. When I first came across this video, like I was still inexperienced, like I watch it, it's a really old video, so he's using an older version of Python. I think it's like 3.4 or something. Now it's 3.12 or 13. So it's really old. So, and the graphics is also quite old, as you can see. I'm not sure.
I'm showing exactly 120.
Right, so it's 2013, and then he's using Python 3.3 or more recent, I guess. So the video is very old as well. So the live coding he's doing, to our standards now, it's not pretty, right?
Yeah.
So, but when I first came across it, like I'm not as experienced, so like I'm watching it and like it's really long, and it seems a bit complex. I don't understand, so I just turn it off. And then I come back to I come across this video again like a year or two later, and I watch it. It's the best thing I watch, and like it's one of my favorite videos on YouTube now. Like I don't watch it often, but I just watch the thing, and then he's live coding things, and then he's going from like the basics on like how functions work and what these like decorators, and like from the basics, and then he goes into more in-depth, like he goes deeper and deeper and deeper. It goes into like more complicated sort of subjects, but in like he does a nice build up to it, right? So it feels gradual rather than just suddenly you're dropped into this rabbit hole.
Yeah.
But yeah, it's really entertaining. Like after I come across it first time, like I don't understand it, and then I'm more experienced, and then I coincidentally just when I was browsing through stuff, I come across it again like 1 or 2 years later. Now I understand every bit of the code that he's writing live, and I understand everything he is explaining, and I'm just amazed by it. And if you go into the comment section, like people are saying the same thing.
Surely he's by far the best speaker or instructor we have in Python.
but the type of thing he's teaching is not something that like 99.9% of people aren't going to be going meta-programming level of coding, but it's just interesting, right?
Yeah.
And by understanding this video, it shows how far I've come with my understanding of Python, the language itself. After this video, like I just love this guy, and like I start watching his other videos, and then he goes into quite like deep subjects and stuff, and I go look up his blog and stuff. So you start watching these videos, and you find people that you like, and then you kind of see what other materials that they've written, and then you kind of I got into thing, right? This in itself is interesting, so and then I look up how I come across this video about Raymond Hettinger. He keeps saying like he's a core developer of Python, and like what's a core developer? I look up that thing, and then there's Python is kind of this organization, Python, or what do you call it? Welcome to Python. Getting started, blah, blah, blah. There's the Python Software Foundation. Grants, become a member, volunteer. I can't find it, but so there's this organization of Python. At first, the founder of Python Guido van Rossum. Have you heard about him?
Yeah.
He's a Dutch guy. He first started Python, and then he was the benevolent dictator for life. This is a thing this is like a concept used in software. Like the founder of the software, they kind of have the overruling power of how they should manage, like in what direction it should go, right? But he's been doing this. He's been in that role for a while because he was the founder, but later on, he got fed up of it. He got fed up of it because people write proposals about adding new features on how to improve things, and then he's the person with the final say, like whether he approves or not, and then this gets implemented or not. And people have opinions, and then there was a particular opinion where in 3.8, this thing called there's this operator. You see here, you see how there's the colon and then the equal sign, and then do I have to do it like this? I forgot how to do this. Yeah, there's this particular walrus operator thing. It assigns the value to the variable, but it also returns the same value to I forgot what the exact functionality of it. I don't use it much. I know it exists, but like there was a proposal to add that feature, and then there was a lot of debate apparently where some people were saying like this is totally useless, like what idiot, thought of this idea and stuff, and there are people who are really for it. There's a lot of like discussion and debate and like heated like arguments and stuff, and then but he was the final person that has the final say, right? So he needs to kind of mediate, but he's been doing that for so long, he gets really fed up with it, like I don't want to do this. Like he approves it in the end, but he doesn't want to do it. He doesn't want to be in this role anymore, right? So and then he said,
so they
like,
created the Python Foundation that does that now?
No, I mean the
Python
Foundation existed before, but like he wanted to change in the governing structure. So now I think there's a steering committee with multiple members that kind of vote on the different things, right? Whether to approve or not, like how Python Foundation and like the direction of where it should go is decided by the steering committee, I think. Guido van Rossum is on the steering committee, I think, but he's not like the dictator of the thing, but just a member of the steering committee, so it's less bad than that, I guess. I don't know if he's still on, but I'm not like I don't know the details of it. It's just like vague memories, and I'm probably getting some of the details wrong, but yeah. So there's like a long history in how the language developed, right? This goes probably the same for R and Java and blah blah blah. They have some sort of structure, right? But like I watch different videos like trying to learn practical things, but I come across these videos that's explaining about the history of the language as well, so I kind of get invested, like it's in itself interesting. So and then you kind of understand how the language has developed. So from the older versions to the newer versions, what are the differences? Like what is new and what didn't exist back then? So this learning the history it helps you with understanding of the language, how it operates as well, and it's practically useful because I sometimes get people like asking me like they have this script, they wrote this script, but it doesn't run. They're getting some sort of error, but they don't understand why it's getting this error because it used to work before. But it turns out because they used to use a newer version of the Python language, but now for some reason they're using an older version and they're trying to run the same script, but it doesn't run because some of the features that they were using was only So it gives learning that history gives you practical use as well. So it's not just out of interest. There's some things you learn out of it as well. So yeah, and then there's that. So there's learning of that, and then.
So could that be that you sometimes, if you start a new project, then you can decide, well, I'm going to just use the newest version of Python. But if you jump into an already existing project where there has been already written a lot of code, you just stick to the version of Python that code was initially written in, right? You're not just going to use the new version. So is that what you mean that you sometimes might be forced to use an older version of Python because you're working on something that has been written already?
No,
version? Or where could you experience that where you feel like it's very useful to understand the changes that have been implemented throughout the versions?
It's not common, the situation I explained that happens. But you know how I'm doing a lot of supporting role in my job as well, where I'm helping other people run their analyses and stuff. Yeah. Because I'm a bit more experienced in like the technical side of things than compared to other biology background. Yeah.
Because you went deeper down.
Yeah. Because it was my interest. But it's just say there were Linux distributions generally come with Python 3.6 installed. So if you don't consciously update it, if you just work with whatever is installed, you end up with 3.6, which is very old. Yeah. So compared to now.
6-7 more.
Yeah. So a lot has changed since then. So it's just there was a few occasions where people would be working in an environment that I set up, for instance, where it's got a bit of a newer version of Python installed, and then I tell them to work on a another virtual machine or something, and then I didn't necessarily, update anything on it, and they just use whatever is there, and then they end up using an older version, and then
makes sense.
they
So like,
complain
why
about,
does this not work on my
Yeah.
computer? We just did that. Makes sense. Yeah.
So now I'm quite deep into this, and then I got like a good understanding about different things, but like I want to know more. Like I want to go down the rabbit hole, and I'm just reading a lot of different things, and then I look up David Beazley, and I have questions about the language itself, right? Because I'm interested about the language itself. I ask why, like, what does import do? What does print do? What is a variable? Like what actually is it? And then to answer those questions, you need to know how Python was wrote. So like, how is Python? It is a program in itself. Like all programs are written in some way, but this is a language. So like, what wrote Python? So it's C. C was used to write Python. So
Yeah.
So like, okay, so this is also on GitHub as well. So you can go through.
I feel like a lot of people not necessarily learning C
Obviously,
anymore,
yes,
right?
obviously, yeah. So I went down this rabbit. So I want to understand more about this. And like one of Raymond Hettinger's video, he goes on saying how he's a core developer, and there's like lots of work that is needed on Python language itself, like a lot of improvements to be made, and changing how the error messages occur so it's more informative, so people more quickly understand and fix the issue, whatever issue they're having. He goes on about how there's like a mentoring system within the Python community where core developers can mentor people, volunteers to work on the CPython implementations to improve it or fix bugs or whatever. And then so like I wanted to do that, so I wanted to learn how CPython works, because mentoring is obviously useful, right? It saves me time learning things. So I would like to have a mentor, but you know how I grew the triangle with beginner, intermediate, like my idea of like advanced expert level is on that sort of level, right? So that's why I see applications.
You see an application with someone
it's just
who did a bootcamp
kind of,
and a few projects. It's not an expert.
So but this is obviously, I understand where they're coming from. Like this is within our bioinformatics community. They may be on like the
seem advanced, but
but in my sort of idea of, I'm looking at the broader community, right? So like that's not advanced. But yeah.
No, that's funny because, I know you a bit now. I would have not said that you were just passing the beginner, like that you're just leaving the beginner sphere of, Python programming. I would definitely thought I would have like counted you in as one of the people who get into the advanced.
Yeah. So it's all about perspective, right? It's all about perspective. Yeah. So
you mentioned that to the applicants once in a while. To applicants.
No. I think I only ever explained this thought to you. Like I had this thought. My boss as well, my current boss. But So one of David Beazley's books is about. He has a book specifically that goes into the details, like the basics of the CPython code. It's been ages since I went through the CPython code, so like I can't find when I was actively like going through it, I did find where the C function, the print function C implementation is, and how like so this is the actual like under the hood of like the print function, and like everything is a object in Python. Like everything is an object, everything is a dictionary. Like it's a Py object under the hood. So like where is Py object within the source code of the CPython? And I went through all that. It was interesting, but later on I got busy, and now learning about all of this gives me diminishing returns for my actual job, right? So it's interesting to me, and if I had the time, I would like to go into more details of it and learn more about it. But it's not useful for my job anymore. Like I think I've reached the sort of saturation point where learning more isn't going to help me in my current job because I'm more research oriented. And for practical uses that would help for me would be to learn more about statistics and data science, that type of thing, because
is that the route you also further want to go, or is it you want to go more into the deeper technical core development of?
If I had the time, yes. It's just generally interesting for me, so I would like to if I had the time and resources, but I don't. Like, I need to feed myself, but like statistics and data science stuff is what I like doing as well, so I want to be good at it as well. So I would have the best of both worlds if I am good with like statistics and data science and analysis type stuff. I know for my job, I know the technical aspects of things, so I am confident in that ability. I just want to be more confident in the analytical side of things as well, so I would be an all-rounder person. I kind of rambled on with Python in particular, but there's also like, you know how I said, unit testing and packaging, these are more broader sort of concept of programming, right? It doesn't just apply to Python. Some details might only apply to Python, but it's, it's conceptually, it's about programming. I go down this rabbit hole of like the Python, just briefly touch, like going into this deep with one language, you different languages, obviously they would have a governing structure, and like they would also have a history and the way they work, and like they must have been written in some way, right? So I don't know the details of how R was written or how it was governed or how Java was invented and stuff, but I know about Python, right? So it kind of bleeds into the other languages. I see a feature in one language, I can compare it with what I already know and identify the difference, right? So learning deep about one thing helps me,
pick up other
stuff. So it's useful. And then there's the sort of language, language agnostic stuff, concepts. People learn about algorithms and data structures. I had a period where I was going through a lot of that as well, but in my limited time of what I've been working 5-6 years in my field now, not that long, I don't think, but during that time I am in bioinformatics and not programming, like proper like developer stuff. But maybe that's why in my career I had like 2 occasions where like I would apply my knowledge on algorithms and data structures. If you're using a high level language like Python, like the data structures are sort of implemented for you. I mean, sets and dictionaries and those type of things are itself data structures. You don't need to like write up like hash maps and stuff like that from scratch, right? You just use what's provided by Python, so you don't really need to know those things. But I was at one point where there is this Google developed this DeepVariant.
By the way, should we switch the
light on?
Yeah.
Okay.
Also.
That's fine. Is it useful, interesting so far, at least?
Yeah, no, absolutely.
Okay.
It's nice to hear about that.
Not something you can hear from.
It's very different.
Yeah.
No, it's a very different. Sorry. It's very different information than you would get from a basic tutorial, like I don't know.
Yeah. So I thought it might be useful for you as well.
And, yeah.
So I was briefly working at like a consulting firm, and so this tool came out developed by Google. It's something called a variant caller. It's something we do in genetics, where we have sequence data and then you kind of it's to find out what genetic variants the person has from like spliced DNAs, like from their spliced DNA. And so Google developed this DeepVariant, which this is an AI model. It does image-based analysis, whereas previously we were all like statistics-based, but this is like a different way of calling variants. So it says DeepVariant supports germline variant calling in diploid organisms. Humans are diploid organisms, and germline is is the hereditary. So there's germline and the somatic. Somatic is generally what you do with cancer cells. So how it's all of your cells' DNAs are the same. But cancer cells, they're mutated and they've mutated enough to clone themselves, and there's different clones within the same tissue as well, because different parts mutate differently, and then they kind of germline is basically just getting your DNA basically, but somatic is generally getting the cancer DNA. So this DeepVariant was made for germline sample variant calling, but the consulting firm I was working for briefly wanted to know whether it was possible to get the idea of this and then to variant calling for somatic cells, so using it in cancer samples instead. So I went through the source code. It's written in mostly C++ and a lot of Python as well, but I don't know C++, but the source code is available, so I just ripping it apart, like running different things and understanding. They have like blogs explaining how this works and stuff as well. So based on the source code, how I understood it, and from the blogs, I'm just writing a proof of concept of the model to apply to somatic cells, somatic DNA sample. So, and then it's kind of like a Tetris thing. DeepVariant. Let's see if they. So this is what they do. It's like they have like bits of DNAs which kind of align to this reference DNA, and then you kind of line them up, and then you see what's different and stuff. And then there's different channels. They say channels, and then like different statistical values for each channel. And so it's kind of like you have chunks of DNA, and it's kind of aligning it to like a reference, right? So you're kind of. I'm not using their code, but I'm just kind of getting their idea and rewriting it from scratch in Python, because I was just making it as a proof of concept to see if it works on somatic cells. This is when I first applied the algorithm stuff I learned on LeetCode. Do you know LeetCode?
No.
Okay. This is this website. It gives you a lot of like coding examples where you need to apply like different data structures and algorithms to solve the coding problems. Like this is what they test in coding interviews and stuff. Big tech companies and stuff. I don't know if they still do, but like
so LeetCode, is that can you go from challenges on LeetCode to
yeah.
Okay.
That's kind of what they do. So I had a period where I tried a lot of these challenges and stuff. And
did you use it in interviews as well, or just for yourself too?
Just to like understand why it is, why it's important, whether it's practical or not. A lot of people say like, why do you learn this? You don't use it at the work and stuff. I still wanted to know. And especially in like our field, we obviously there's even less use of these things, even this knowledge in our field, because we're not like a full grown like tech type work, right? We're more research focused. We use higher level language like Python and R instead of like low level language like C++. This particular like problem, I had to use some of the algorithmic stuff that I learned from these type of challenges. And then there was like one other case when at my current work, one of my colleagues asked me, like, he's got this, he needs to run this analysis in like these different pairs and stuff. He was describing it, and then it kind of occurred to me that this is a graph problem. So, but it's because I learned these things prior, I could, when he was describing it to me, I kind of connected the dots, right? But I don't think it's that useful to, like, I don't think it's necessary at this point. Like what you want to do, probably you wouldn't need to go down that path. Like,
Maybe not.
Yeah, it wouldn't be useful for you, I think. Yeah.
But I think at some point it's still, if you learned to a certain point, I think it's still interesting to know, develop a deep level of understanding of how things work.
If you are willing to go down that rabbit hole.
Yeah.
But what the other stuff that was useful, design patterns.
Maybe also like general questions, or like, it's like usually when you get stuck with problems, like, do you have certain resources that you would use repeatedly for, I don't know, understanding how to solve the problem or how to get unstuck? Was it mostly like, because it was mostly related to your field, you knew the basics of Python, for example, so it's more related to the field, not to the coding?
No. It's definitely, there's definitely a lot more coding related problems that I would have to solve. But whatever, it doesn't have to be Python. Even like with Python, or there's like third-party libraries, so let's say pandas. Like this is a package, but it's a big thing, and they have like extensive documentation, and Python itself has their own official documentation. They have a lot of resources, and I think beginners, it's easy to overlook these official documentations because it's very dense. So you look at it and
I think sometimes it also is a lot, right?
Because
documentation is there's everything.
Yeah. So
sometimes it's a bit overwhelming, right?
Yeah, so it's understandable why they overlook it, but the official documentation is very useful. Going through it, you might pick up something that you didn't previously know, and
so you were using that a lot, like just
I eventually used it a lot. I eventually referenced it a lot. So before, when I was a bit more inexperienced, obviously, like I have a particular issue, like an error, I'll just search it on Google and then try to find relevant pages or Stack Overflow answers that are relevant to my. If you're doing something specific, obviously you're not going to get an answer for it because no one else is doing that specific thing as you, for instance.
Have you used AI tools for that? Like where you just put in certain code and ask, hey, why is that not working? I want to create this.
Yeah. So now, because ChatGPT is out and stuff, and you have those options, a lot more easier to learn. So now I use it a lot as well.
For debugging?
Yes, a lot of debugging and just like telling it to do simple coding stuff that I know I can do myself, but it's just more time efficient if I just tell it to like describe it to it and then tell it to write the bulk of it, and then I'll just copy and paste it, and then I would just modify it slightly for my own use case in that sort of way.
Some people are saying, especially for beginners, that they would not necessarily recommend them using AI for help when they're learning to code, because they might end up not learning the basics and fundamentals properly, because AI just writes the code for them, they use the code, and then without fully understanding what's happening.
It always depends, right?
It's how you use it, right? If you really let ChatGPT as well explain why your code was wrong and what the solution they're providing is about.
I have a lot of experience in learning things, like looking up things, like trying to find the right material or trying to find these specific information. I have a lot of experience in feeling the frustration and stuff, and was hoping like the reason for a mentor is so that you have a person that you can sort of rely on and help you with if you're stuck in like specific situations, right?
Also someone you can bounce your thoughts back off.
Yeah. So I have all of the experiences. I had a period where I had a mentor, bouncing ideas or just asking for help when I needed it. I also had a long period where I was doing everything on my own. I was like banging my head against the wall because trying to solve this issue on my own, and there was no one else to help me, and I had to do this alone and stuff. I had both of that experiences, and
so you also had these moments where you literally were bouncing your head against the wall
yes.
because it's not working.
Yes. So because of that experience, I and I also have experience in having someone that I could delegate my work, like an intern or whatever. Like I would describe what the intern needs to do, what code to write, and how to write it. If you get stuck, you can tell me, and then I'll help you. And like I was the mentor. I had a mentor role as well myself, right? So I had all these different experiences. Obviously, if you're a beginner and you're using ChatGPT and just delegating all of your work, obviously you're not going to learn, right? But using ChatGPT, I was did I tell you about the non-profit organization that I help out in making the website, right? Yeah. So the science outreach non-profit organization. So I made a website for that organization. I'm a bioinformatician. Like, what do I know about web development? So I knew like the very basics and the tutorials available, but we needed a specific functionality for the website, right? And there isn't a tutorial for the exact same website I'm trying to make, so I need to learn these things myself. Before ChatGPT, obviously it was really difficult. I had to learn everything on my own. Like tutorials are helpful to only certain degrees because there are these specific things that I need to implement, but there isn't exactly a tutorial for that. So I need to, obviously I'm faster than just any beginner trying to learn because I know the basics of still it's time consuming, right? And I'm busy. But ChatGPT comes along, and then I kind of use it for certain things. I use it as a mentor to teach me things. I know how to formulate specific questions. So I ask it those specific questions. It gives me a concise answer. I understand it, and I can do stuff on my own. But there are simple stuff that I want to, like, I know how to do myself. Better for me to just delegate the work to ChatGPT and do that, and it just speeds up. It increases my efficiency, right?
So things you really know how to do, and they're fairly simple for you. You do delegate it to ChatGPT and just write the code for it. So you give it concrete instructions.
And like things that I need to understand, I ask questions. I'll just bounce things off of it. It gives me clear answers, and then I can do further research and try different tests and stuff, and to get a better understanding of myself. I don't think this is going a bit off topic, but whatever. I don't think AI is going to replace us, but it is going to increase the gap between experienced and inexperienced, because obviously beginners, they don't know how to formulate. They don't know what they don't know, right? So they don't know how to formulate the specific questions they might have. So, and they might just think to delegate a lot of the work without knowing how to do it themselves. So they're losing that opportunity to learn, right? So, but whereas more experienced people, they know how to learn, they know how to use ChatGPT or like large language models more efficiently to increase their own productivity, so they'll just get better and better more quickly than beginners. But so you need so I think it's going to increase the knowledge gap.
So back to just like you would back in the days would just like always use the documentation to go. I mean, you started using that later, but you said that's a very useful tool.
Yes, it's very useful.
You get stuck.
Official documentations, there's a lot of good information in it, so
Also notice, of course, you can do as a beginner, if you don't know anything, you can let ChatGPT write things for you when you construct it, when you tell it to do so. But I notice when you go through documentations, you see what's possible. Like, what is there? Like when you don't know that, like ChatGPT won't tell you what else you could do. It just does what you tell it to do. But if you don't know, like,
Yeah.
what functional commands I could create with Python. Then.
You need to give yourself time to do some general reading or just general, watching. You know how I said like I just generally watch a lot of Python videos. Doesn't necessarily have to like it. You don't know what is going to be useful later on. So like general reading is just overall useful. Just you need to make yourself time for that as well. So to get better at things. Design patterns are something that would be useful to know. Like just understand what different design patterns there are and what they are for. Let's just check Wikipedia. This is like abstract factories, builders, factory methods, like adapters, wrappers, bridge, composite, decorator, like these things, just facade, flyweight, just there are these concepts. I'm not going into any of the details here, but because this is a whole nother subject, but just when you're building stuff, you kind of see that it's your workflow, your pipeline, or something is inefficient, and you feel like there is a way to do stuff more efficiently, but you just don't know how. That's kind of when I felt the need to like look up what algorithms are and what data structures are, and then I come across like these things called design patterns. So what's a design pattern? What is decorators? What's front controller? What are these things? And then you watch videos, and then you see people talk about practical examples on like how these are used, and then you imagine like how your pipeline works, so you kind of imagine how you can implement that in your thing. Would it help? Would it not? So it's a lot of sort of connecting dots, just getting a lot of different information, just kind of experimenting. A lot of experimenting. You should learn how to experiment. Like what I did with like printing the shit out of everything. Just throwing questions at like very basic things, like do you really understand it?
Yeah, that's true. That's very important. I think people just stick to the beginning. It's easy to just stick to these tutorials and do exactly what people have shown you before, and not just be creative and try to understand it really holistically.
Like I said, I didn't plan.
Like
but I just kind of had like big, broad sort of pictures of like what topics to cover, and I think I've gone through everything.
That's pretty solid.
Yeah, that's good.
Well, thanks a lot. It was nice to chat about that.
Hope it was useful.
No, absolutely. It's just for someone who's always has been at the absolute beginner level. It's always it's comforting to hear it from people who have been doing it for a lot of years already. And interesting to see that you would see yourself as someone who's just starting to be intermediate. Because I do think I see your point of like there's so many tutorials and books where they say like from beginner to expert in 6 months, and it's like
7 years in, I still think I'm intermediate.
And I could imagine that people come into the interview with a CV and then I've done a few projects, but then maybe a few boot camps, read a few books, and they're like, I'm an expert. But do you then use this sometimes, and then you feel like, okay, I'm going to ask like some trick questions to see how much of an
of course,
definitely. Because I kind of feel like, so you call yourself an expert, do you know these things?
I throw in like some basic stuff and they can't answer it. It's like, but it's expected. But like I said, like everything's in perspective, right? So within the bioinformatics community, I do think they are on like some of them are on like a higher level compared to like other bioinformaticians, right? But if you look at it more broadly, obviously they're not, like they're still beginner level or whatever. But yeah, I mean, this is our field, and
yeah, I mean, it also depends if you mean Python programming, or if you mean like Python, data science. Like, yeah, okay, you may be close to an expert in this field, but not generally Python programming, which is a lot broader, probably. Yeah. Actually, so like, and you just because based on your career so far, you're gonna want to continue in bioinformatics field, also research field, and not go deeper into like not software development, but understanding the technical side even deeper.
So I am.
It seems to be that's where your interest also is. Like you could have as well studied just informatics. And I thought you.
Yeah.
Really
So yeah, I think I am going to go down that path. I say bioinformatics, but like it's kind of like data science in biological field, right? What I'm doing, but the data science stuff can apply to other fields as well. So I think if there is I can see myself going into just data science, but not particularly in something biology related.
Yeah.
But I kind of do have the skill set, and getting exposed to other area
machine learning.
Yeah.
That's also related, right?
Yeah.
To data science, obviously.
Like I said, with the going down the rabbit hole of like CPython is a diminishing return for me now, because I am knowledgeable enough to handle all the type of like technical stuff that are thrown at me in my current job. So I get more out of more returns if I learn, machine learning or statistics and that type of stuff.
You're doing that right now as well?
Yeah, so that's what I'm gonna focus on 2025, I think. But
that's your New Year's resolution.
Yeah.
I mean, you have been doing that already, right, for a long time, no?
Not a lot this year. I kind of want to next year, but like this year I was doing a lot of exercising and violin.
Yeah.
So I think I'm gonna study more 2025. Okay.
Nice. Thanks a lot.
Wrap it up.